In this tech tip, I'll be demonstrating key information on creating workplanes in EDGECAM using solid models. Workplanes have so many uses in CAD and CAM software. Specific to EDGECAM, we use workplanes when we're orienting the part and getting it aligned the way we want, as well as when we are creating geometry and feature recognition. We also use workplanes when we're building toolpath. The initial workplane is really important. That establishes the direction of X, Y, Z, and any rotary axis movement, as well as the origin for the CAM setup. But we can shift the workplane during the setup. Could be, for example, moving from the main to a sub-spindle, or changing the rotary axis direction on a machine tool, whether it's a mill or a mill turn. Could be changing the work coordinate system that's active, shifting the datum somewhere else, multi-part machining, and even multiple relational setups. All of these are things that workplanes enable us to do. Those are not things we're going to cover here. In this tech tip, we're going to cover the basics of creating and editing workplanes. And once you know that, these are some of the things you'll be able to do, and we do intend to cover them down the road in future tech tips. So let's go explore creating and editing workplanes. The geometry of this part requires that tools approach from various directions. The render by slope overlay is a graphical way to quickly show that some faces shown in yellow are parallel with the z-axis of our current workplane, some faces in silver are perpendicular, and others are not. So focusing where the blue hole is, notice that that hole comes through the part at an angle different from our workplane. We also see some green faces where they're planar or flat faces, but they're not parallel or perpendicular with our z-axis, and they have cross holes that go through them. So we're going to need to use the rotary axis index capabilities to get them. Then there's also a partially exposed cross hole. All of these areas are places where we're going to need to use workplanes. The setup window has ability to snap a datum to the part, and that is operating on one of the automatic workplanes. Whenever you start a new EDGECAM part, you have top through drawing, and the first solid you load will have one called component datum, as is the case here with this part that contains a single solid. That is the active datum, and I'm going to point out that that affects feature recognition. When I go to run find features and ask for simple pockets and vertical holes, all of the pockets and holes that are accessible in the component datum workplane, the workplane is a property of the feature, all of those features that are accessible from this plane are selected. This also means that some holes, such as the holes perpendicular to this face, are not selected because they do not lie in this workplane. In order to get those features, you need a workplane. And so we're going to start by creating a workplane. When we create a workplane, there's a few things you have to do. The command's very flexible, but at a bare minimum, we need to give it a name. The name is for you. Be as descriptive as you wish. It's a mill-based workplane, so the dimension should be 3D. And then, how do I want to construct it? Face normal is the best option to use when you have a planar face that you want the z-axis perpendicular to. So I'm going to choose that, and you also have the option of origin. I'm going to show what happens when that is on. After selecting OK, the first prompt is for the face that the workplane will be perpendicular to. So I'll go choose that face, and then the next prompt is for where the origin is. And so here I'll just move and snap to the mid of the upper edge. And notice that not only is the workplane perpendicular to that face, but its origin is at that location. And then to go back to the find feature command and leave it configured exactly the same way, now feature recognition is done in this active workplane. Again, notice the plane. If we change the rendering to make it easier to see the features, notice how the features are lined up to the z-axis of the plane. If we edit the features and we look at the geometry page, we can see that the working height or level is taken from the origin point of the workplane. Well, what if we decided that the origin needs to be changed? How do we do that? We use the edit workplane command, and we choose the workplane to modify, and then we choose what to modify about it. In this case, only change the origin. And after pressing OK, I want to base it on the world system. So what I'm going to do is I'm going to hit X, Y, or Z on the keyboard. Pops up coordinate input. We'll choose world coordinate system. We'll choose 0, 0, and 0, and that locks it into the world coordinate system. I just changed the origin of that workplane. The question is, what does it do to the features? Well, if I double-click the mouse over any of the features and go look at the geometry page, the feature is still valid. Its working height is updated to the feature's height off of the workplane. Awesome. Well, that set of features is only the features in that single face. We need to create additional workplanes for other faces. So let's repeat this and make another workplane for the next item over to the right. It will also be mill in 3D and also face normal, but I do not want to change the origin this time. And the reason is that I don't want the origin to change. So don't even ask me. All I need to do is pick the face, and instantly the workplane is created without any shift in the origin. When we go to find features, there are some new features created with alignment to the z-axis of this workplane, 2 new groups of holes. Now, another way to look at the z-axis alignment is to go up to View Properties and turn on Track Workplane. This sets up a view where we look down the z-axis of the active workplane with X to the right, Y going vertical, and we look at things from the tool perspective. Notice that we can line up with some holes, but not the ones to the left because they're a slightly different pitch. Again, demonstrating feature recognition based on workplanes. When we return to an isometric view, I want to continue with another group of workplanes. So I'll make a workplane again, same criteria, we'll give it a name. We will use the face normal for perpendicularity. No need to shift to the origin, and I'll pick the next face to the right. The workplane's created, and when we find features, I'm going to give you a new tip. Instead of switching tabs, go to Quick Search and type the name of the command you're looking for. As soon as I type Find, I see the Find Features command, and I can easily choose it and find the features in this plane. To render them and make them easier to see, there are some perpendicular holes, and there's also a pocket, perhaps from the initial one, that I don't need. Let's blow that away. There's not a feature through the cylindrical hole, and when I turn on IntelliSnap and look at the axis that's reported, notice that there's no hole number there. Instead, there are smaller numbers. Those represent vectors. The vectors split somewhere else, but it's not in the z-axis of the current plane. If I hover over the holes that we did find features in, their axis does have the hole number in the z-axis because they are parallel to the z-axis of our plane. This face has a normal representing perpendicularity, again with vectors, and this face is perpendicular to the plane, but this cylindrical face does not have an axis lining up to this plane. We will need a unique workplane. It's not that feature recognition missed something. That hole is not lined up to this workplane. So we're going to make a workplane, and we'll pretend that we don't have the counterbore flat at the back end, or maybe the counterbore flat is more of a drilled angle pilot. What do? You use face axis. It's a different method, but we use face axis when we don't have a perpendicular face. We want the z-axis to line up through a cylinder. I'll pick the cylindrical face. The workplane's created. Now, that plane lines up to that hole. It lines up perfectly. If we were to look at the holes in IntelliSnap, we see that the axis is now hole number. It's in the plane of the z-axis. Great, the workplane's created, but look at the z-axis direction. It's 180 degrees out. It's not uncommon for me to hear customers that have tried face axis and they say EDGECAM always gets it wrong. What is happening is that the relationship of the cylinder we pick to the origin determines direction. The z-axis direction will come from the cylinder pointing to the origin, and that's why it goes that direction. So what we're going to do is simply go and edit the work plane and rotate it 180. Again, this may be something you do if you use this method that I just showed to create work planes with face axis. You'll want to go edit the work plane and then say what's different. In this case, the only thing I need to change, right, nothing else on that page, go to rotate and rotate 180 around X. Piece of cake. So I create the face axis. If I know the origin's going the wrong way, I just rotate it 180 around the X axis, and then we can proceed forward with feature recognition. Now, instead of using quick search, I'm going to right click where we get access to recently used commands. Yet another tip. And I'm going to go grab the Find Features command from here. We'll simply press OK. And wait a minute, no features created. Why is that? Well, it's because it's not a closed cylinder, and my feature find configurations are not set up to detect that, so no worries. We'll follow the guidance from EDGECAM Mill Fundamentals and move on to using manual features to fill in any additional areas that we want. The manual feature doesn't care whether the cylinders are full or partial. We now have a feature that's in that work plane that we can use to get toolpath. When I get a solid model and have to create work planes, I find that this progression works really well. Do I have a flat face that I can use to set Z perpendicular to? If not, do I have a face that I can use as a cylindrical face to establish the axis of the Z-axis? And if not, perhaps I have another work plane that I can use to build the new one that I need. There's other methods of making work planes in the create work plane command, and you're smart, I'm sure that you'll figure them out. But just a couple key pointers. If you're making a mill work plane, it should be 3D dimensions. And if it's a turn work plane, make sure to set the dimensions to 2D. Do you have questions on this or other topics? Please contact us to discuss. We would love to hear from you.